Hello and welcome. Tonight, we'll be exploring one of the most beautiful and mysterious worlds our solar system has to offer, Saturn, the great ringed giant that has inspired wonder ever since human beings first looked toward the night sky. From a distance, Saturn seems almost peaceful. Wrapped in soft golden clouds and surrounded by luminous rings, it appears calm enough to drift silently through the darkness forever. Yet beneath that graceful appearance lies a world unlike anything we know on Earth. Winds race faster than the speed of most passenger airplanes. Storms larger than entire planets quietly circle its poles. Invisible forces stretch millions of kilometers into space, while hidden oceans may exist beneath the frozen surfaces of distant moons that orbit this remarkable giant. What makes Saturn especially fascinating is that every new discovery seems to deepen the mystery rather than solve it. The more closely scientists have studied its rings, its atmosphere, and its family of moons, the more they have realized that Saturn is not simply a planet. It is an entire system of worlds, all connected through the gentle but relentless pull of gravity. Even today, long after one of humanity's greatest space missions came to an end, many of Saturn's greatest secrets remain beautifully unresolved. So, find a comfortable place to rest. Allow your thoughts to slow like clouds drifting across an evening sky. And let's gently begin our journey into one of the most fascinating questions in planetary science. For thousands of years, Saturn has stood apart from the other wandering lights in the night sky. Long before telescopes revealed its magnificent rings, ancient civilizations watched its slow journey across the heavens and gave it names inspired by gods, kings, and the passage of time itself. Unlike the brilliant glow of Venus or the reddish spark of Mars, Saturn moved with quiet patience, taking nearly 30 Earth years to complete a single journey around the Sun. It became a symbol of endurance, mystery, and the vast rhythms of the universe. Today, powerful spacecraft and giant observatories have allowed us to know Saturn far better than those early skywatchers ever imagined. And yet, despite all we have learned, there remains something almost dreamlike about this distant world. It is a place that seems familiar because of its famous rings, yet almost everything about it challenges our everyday experience. Imagine, for a moment, that you are slowly approaching Saturn from deep space. At first, it appears as a pale golden sphere, surrounded by a delicate halo of light. As the distance closes, that halo begins to separate into countless shimmering bands. The rings stretch so far across space that they would easily span the distance between Earth and the Moon many times over. From afar, they seem smooth and solid, almost like the grooves of a giant record, but appearances can be wonderfully misleading. Long before we reach those rings, another astonishing fact quietly changes the way we think about this planet. Saturn is enormous. More than 760 Earths could fit inside its vast volume. If our own planet were placed beside it, Earth would seem surprisingly modest, almost like a marble resting next to a great golden lantern. Yet despite its immense size, Saturn is composed mostly of the two lightest elements in the universe, hydrogen and helium. These simple gases, born in the earliest moments of cosmic history, make up nearly all of the planet we see today. This unusual composition gives Saturn one of its most famous characteristics. Averaged across its entire enormous body, it is actually less dense than water. You may have heard the delightful statement that Saturn could float if an ocean large enough existed. Of course, no such ocean could ever be found. There is nothing remotely large enough anywhere in the solar system. But, as a thought experiment, it offers a gentle reminder that size and weight are not always the same thing. Saturn is unimaginably massive, yet its material is spread throughout an equally unimaginable volume. It is one of those rare scientific facts that feels almost playful, inviting us to see the universe from a slightly different perspective. As our imaginary journey continues, Saturn grows steadily larger until it fills almost the entire sky. Its colors become richer. Soft bands of cream, pale gold, gentle amber, and muted brown wrap around the planet like broad brushstrokes painted across an enormous canvas. Unlike the sharply contrasting stripes of Jupiter, Saturn's cloud bands blend together with remarkable subtlety. They resemble layers of morning mist stretching across distant hills, giving the entire planet an almost peaceful appearance. It would be easy to assume that this is a quiet world. It is not. Hidden beneath those graceful clouds are winds that race faster than many aircraft ever built. Vast storms can survive for months, sometimes even longer, while deep inside the planet, pressures become so immense that familiar gases begin behaving in extraordinary ways. Yet from millions of kilometers away, Saturn keeps all of that turbulence hidden behind an elegant veil of gold. Perhaps the greatest surprise awaiting any visitor is that there is nowhere to stand. When we picture planets, we naturally imagine landscapes, mountains, valleys, oceans, shores. We expect solid ground beneath our feet because every world we have ever known has offered one. Saturn does not. There is no rocky surface waiting beneath its clouds, no hidden continent, no silent plain where a spacecraft might gently settle. Instead, Saturn is more like an endless atmosphere that gradually grows deeper, warmer, darker, and denser. Flying toward the planet would feel less like approaching a mountain and more like descending into an infinite ocean of clouds. Layer after layer would surround you, each one thicker than the last, while the pressure quietly increased all around. The deeper you traveled, the more the atmosphere would press inward from every direction. There would never be a single moment when you could point and say, "Here is the surface." The transition is gradual, almost seamless, as if the sky itself slowly transforms into something entirely different. It is a beautiful reminder that nature rarely draws sharp boundaries. More often, it changes one gentle step at a time. This strange world, where clouds become deeper than oceans and familiar gases are transformed by unimaginable pressure, invites us to rethink what a planet can truly be. Saturn is not simply a larger version of Earth. It follows a completely different set of rules, shaped by immense gravity, extraordinary temperatures, and billions of years of quiet evolution. And as our gentle descent continues, those soft golden clouds that seem so calm from afar will soon reveal an atmosphere filled with powerful winds, astonishing storms, and one of the most remarkable weather systems ever discovered anywhere in the solar system. As we continue drifting towards Saturn, the soft golden bands that looked so peaceful from millions of kilometers away begin to reveal an entirely different personality. The gentle colors remain, but now they seem alive. Thin layers of cloud slide past one another. Broad currents wrap around the planet in graceful ribbons. What once appeared perfectly still is, in reality, a world in constant motion. On Earth, weather is something we experience day by day. A calm morning may become a rainy afternoon, and a passing storm is often forgotten within a few days. Saturn follows a very different rhythm. Here, weather unfolds on a scale almost beyond imagination. Some of the winds racing through Saturn's upper atmosphere can reach more than 1,800 kilometers every hour. To picture that speed, imagine the fastest winds ever recorded during Earth's most powerful hurricanes. Now imagine winds that can move even faster, stretching around an entire planet instead of a single coastline. These invisible rivers of air circle Saturn continuously, flowing in broad bands that have persisted for far longer than any human lifetime. Despite such incredible speeds, there is a surprising sense of elegance to Saturn's atmosphere. The clouds do not appear chaotic at first glance. Instead, they form smooth horizontal layers that gently wrap around the planet, almost like silk ribbons carried by a slow current. Only when scientists measured their movement did they realize just how energetic this seemingly tranquil world truly is. Every so often, Saturn reminds us of the immense power hidden beneath those quiet colors. Roughly once every few decades, the planet experiences an enormous atmospheric eruption known as a great white spot. A brilliant storm suddenly blossoms across the clouds, expanding until it stretches around much of the planet. Imagine watching a small puff of white paint slowly spreading across an entire globe until it becomes visible from millions of kilometers away. These rare storms release tremendous amounts of energy and gradually reshape the surrounding atmosphere before quietly fading once again into the golden landscape. Lightning also flashes deep inside Saturn's clouds. Although no one could ever stand beneath those storms, instruments aboard visiting spacecraft have detected powerful bursts of radio energy produced by lightning far stronger than many bolts seen on Earth. Somewhere beneath the visible cloud tops, enormous thunderclouds rise and fall, hidden behind layers so thick that only their electrical signatures escape into space. Yet even these remarkable storms are overshadowed by one feature that has puzzled scientists ever since it was first observed. Near Saturn's North Pole lies an immense storm unlike anything known elsewhere in the solar system. Instead of forming a circle, it traces the outline of a nearly perfect hexagon, a six-sided shape. At first glance, it almost looks artificial, as though someone carefully drew a giant geometric figure across the clouds. But this astonishing pattern is entirely natural. Each side of the hexagon stretches for thousands of kilometers. The entire structure is so large that several Earths could fit comfortably inside it. At its center, another enormous cyclone slowly rotates, surrounded by the six remarkably straight edges that have fascinated researchers for decades. The most extraordinary part is not simply its shape, it is its persistence. Storms usually change. They drift, weaken, strengthen, or disappear. Saturn's hexagon, however, has remained visible for many decades. Spacecraft separated by generations have photographed the same mysterious pattern, suggesting that it has endured far longer than anyone first expected. Scientists have recreated similar shapes in laboratory experiments using rotating fluids, showing that nature can indeed produce elegant geometry under the right conditions. Yet no explanation fully captures every detail of Saturn's remarkable atmospheric design. Like many of the planet's greatest wonders, the hexagon quietly reminds us that nature still holds secrets beyond our complete understanding. As beautiful as these cloud tops are, they hide a much deeper story. Imagine descending slowly beneath them. The sunlight begins to fade. The golden colors soften into muted shades of gray. The atmosphere grows steadily thicker, not suddenly, but so gradually that each layer seems to blend into the next. It feels a little like diving beneath the surface of a calm sea. At first, the water offers only gentle resistance. Then, with every Saturn, behaves in much the same way. As we sink deeper into its atmosphere, the pressure quietly builds until the familiar gases surrounding us begin behaving in unfamiliar ways. Hydrogen, the simplest and most abundant element in the universe, no longer acts like the light gas we know from laboratories on Earth. Under unimaginable pressure, it is compressed closer and closer together. Eventually, it begins behaving less like a gas and more like a flowing liquid. Deeper still, something even more remarkable happens. The pressure becomes so immense that hydrogen starts carrying electricity, behaving almost as if it were a liquid metal rather than an ordinary gas. There is nothing quite like this in our everyday experience. Perhaps the closest comparison is watching soft clay gradually become harder as it is squeezed, although even that falls far short of describing the extraordinary transformation taking place deep inside Saturn. Nature is not changing hydrogen into a different substance. Instead, the immense pressure simply persuades it to behave in an entirely new way. Hidden far below the clouds, This vast ocean of electrically conducting hydrogen quietly plays one of the most important roles in shaping the planet. Although no human eye will ever witness it directly, scientists believe it helps generate the invisible magnetic field that surrounds Saturn and extends far into space. Still deeper, another slow process unfolds with remarkable patience. Helium, which is gently mixed throughout the upper atmosphere, gradually separates under these extreme conditions. Tiny droplets form and begin sinking farther into the planet's interior. It is sometimes described as a gentle rain, not rain made of water, but slow, silent droplets of helium falling through the deep interior over immense spans of time. As those droplets sink, they release energy, adding warmth to the planet from within. It is one of the reasons Saturn shines with more heat than sunlight alone can explain, quietly carrying its own internal warmth after billions of years. From the outside, Saturn appears calm, graceful, and almost delicate. Yet hidden beneath its beautiful clouds lies an invisible world where familiar materials behave in unfamiliar ways, where gentle rains fall through darkness no human will ever enter, and where extraordinary forces patiently shape the giant planet from the inside out. And somewhere within that unseen interior, another mystery quietly waits, one that reaches far beyond the clouds and extends millions of kilometers into the surrounding darkness of space. If we could somehow continue our impossible descent beneath Saturn's cloud tops, we would eventually leave behind the familiar idea of weather altogether. The bright clouds would slowly disappear above us. Sunlight would become weaker, fading into a warm twilight before finally giving way to darkness. There would be no dramatic boundary, no invisible doorway separating one layer from another. Instead, the atmosphere would simply become denser, warmer, and heavier with every passing moment, like walking deeper into a forest where the morning mist gradually thickens until distant trees quietly disappear from view. One of the most fascinating things about Saturn is that it reminds us how different the universe can become once pressure begins to rise. Here on Earth, pressure changes are usually modest. Climbing a mountain or diving beneath the sea certainly changes the environment, but the materials around us remain recognizable. Water stays water, air remains air, rocks remain solid beneath our feet. Inside Saturn, those familiar rules slowly begin to dissolve. Hydrogen, the simplest and most abundant element in the universe, fills much of the planet. Near the cloud tops, it behaves much as we would expect, existing as a gas. But as gravity gently compresses everything below, hydrogen is squeezed closer and closer together. Imagine holding a soft cushion in your hands. At first, it gives way easily, but with steady pressure, the tiny spaces inside begin to disappear. The cushion becomes firmer, denser, and more compact, even though it is still made of the same material. Something similar happens inside Saturn, although on a scale almost impossible to imagine. The deeper we descend, the more tightly hydrogen is compressed, until it no longer behaves like the light gas we know on Earth. Instead, it gradually becomes a flowing liquid hidden beneath thousands of kilometers of atmosphere. Still farther below, the transformation becomes even stranger. The immense pressure persuades hydrogen to conduct electricity, almost as though an invisible ocean has become metallic without ever turning into solid metal. Scientists often describe this remarkable state as metallic hydrogen, but the important idea is surprisingly simple. Under extraordinary pressure, familiar matter begins behaving in unfamiliar ways. It is one of nature's quiet reminders that the universe is often more creative than our everyday experience suggests. Hidden within this vast ocean lies one of Saturn's greatest engines. As electrically conducting material slowly moves deep inside the planet, it generates an enormous magnetic field that stretches far beyond the visible atmosphere. We cannot see this invisible shield with our eyes, yet it surrounds Saturn like an immense protective bubble extending millions of kilometers into space. We will explore that invisible world soon. For now, our journey continues even deeper. Long ago, scientists noticed something curious about Saturn. The planet gives off more heat than it receives from the distant Sun. At first, this seemed puzzling. After all, Saturn orbits nearly 10 times farther from the Sun than Earth does. Sunlight arriving there is much weaker, bathing the planet in a gentle glow rather than intense warmth. Yet Saturn quietly shines with extra heat, almost as though it carries a hidden furnace inside. Where does that warmth come from? Part of the answer appears to lie in an extraordinary process taking place far beneath the clouds. Mixed throughout Saturn's interior are vast amounts of helium, one of the lightest substances in the universe. Under the tremendous pressures found deep inside the planet, helium no longer remains perfectly blended with hydrogen. Instead, tiny droplets slowly begin to form. Imagine watching droplets gather on the inside of a cool window during a quiet evening. Each tiny drop forms gradually before slipping downward under its own weight. Inside Saturn, something similar happens on a scale far beyond imagination. Countless droplets of helium slowly sink toward the planet's deeper interior in what scientists often describe as helium rain. This is not rain in the familiar earthly sense. There are no clouds overhead and no raindrops falling through open air. Rather, it is a slow separation occurring deep inside the planet over immense stretches of time. As those droplets sink, gravity gently pulls them farther inward, releasing energy along the way. That released energy becomes heat. For billions of years, this quiet process may have helped Saturn remain warmer than sunlight alone could explain. There is something wonderfully peaceful about the idea. Deep inside a planet that has existed since the earliest days of the solar system, an invisible rain has been falling patiently for billions of years, unseen by any eye, unheard by any ear, yet slowly helping to keep the giant world warm. Modern discoveries have revealed another surprise waiting beneath these hidden layers. For many years, scientists imagined Saturn as having a clearly defined rocky core, rather like a peach with a hard stone at its center. Recent measurements suggest the picture may be much gentler than that. Instead of a sharp boundary separating rock from gas, Saturn's center may gradually blend together. Rock, ice, hydrogen, and helium appear to mix across an enormous region, creating what researchers sometimes call a diffuse or fuzzy core. The name may sound unusual, but the idea itself is beautifully simple. Imagine pouring cream into a cup of coffee. At first, the cream forms pale, swirling ribbons. Slowly, those ribbons spread outward until it becomes impossible to say exactly where one ends and the other begins. Saturn's deep interior may resemble that quiet blending far more than a neatly layered structure. Nature, once again, prefers gradual transitions over perfectly straight lines. These discoveries have changed the way scientists think not only about Saturn, but also about the birth of giant planets throughout our galaxy. If Saturn formed this way, perhaps many distant worlds followed similar paths, quietly growing from swirling clouds of gas and dust billions of years ago. The deeper we travel into Saturn, the more remarkable it becomes. A world that first appeared to be little more than a beautiful sphere wrapped in elegant rings now reveals hidden oceans of electrically conducting hydrogen, gentle helium rain falling through darkness, and a vast interior that refuses to fit neatly into our simplest models. Yet one mystery rises above all the others. That invisible ocean deep inside the planet appears to generate a magnetic field unlike any other known giant planet. A field so perfectly balanced that even today it continues to puzzle the scientists who study it. Like so many of Saturn's secrets, the closer we look, the more quietly extraordinary it becomes. There is something quietly fascinating about the things we cannot see. On Earth, we rarely think about gravity because it is always there, gently keeping our feet on the ground. We rarely notice the air surrounding us until the wind begins to blow. And almost no one spends much time thinking about Earth's magnetic field, even though it silently protects every living thing from streams of energetic particles arriving from the Sun. Saturn has its own invisible shield. Only this one is so enormous that it stretches millions of kilometers into space, surrounding the planet and much of its remarkable family of moons. If human eyes could somehow see magnetic fields, Saturn might appear wrapped inside a vast glowing cocoon. Long, graceful lines would extend far beyond the clouds, bending and flowing as they met the constant stream of particles carried outward by the solar wind. The solar wind is not really wind in the familiar earthly sense. There is no breeze to feel and no air to stir. Instead, it is a continuous flow of tiny charged particles released by the Sun, traveling across the solar system every second. Every planet experiences this invisible stream, but each responds differently depending on its own magnetic field. When those particles encounter Saturn's immense magnetic shield, they are gently redirected, flowing around the planet much as water divides around a smooth stone resting in the middle of a quiet stream. Most of the time, this interaction happens silently. Occasionally, however, it creates something beautiful. Near Saturn's poles, energetic particles spiral downward through the upper atmosphere, causing faint curtains of light to shimmer high above the clouds. These are Saturn's auroras. Like Earth's northern and southern lights, they dance across the polar skies. Although they glow in colors our eyes would struggle to see without special instruments. From afar, they resemble delicate crowns of light, quietly circling the top of the planet, appearing and fading as invisible particles continue their endless journey through space. It is remarkable to think that something completely invisible can produce something so beautiful. Yet the magnetic field itself is perhaps even more extraordinary than the auroras it creates. Scientists believe that this invisible shield is generated deep inside Saturn, far beneath the clouds we explored earlier. There, within the enormous ocean of electrically conducting hydrogen, powerful currents slowly circulate through the planet's interior. As the giant world spins, these moving currents generate magnetism on a truly planetary scale. The basic idea is surprisingly familiar. Imagine turning the handle of an old bicycle generator to power a small light. Motion creates electricity. On Saturn, nature performs something similar, although on a scale almost impossible to imagine. Instead of a small metal coil, an entire planetary interior slowly moves over billions of years, quietly generating an invisible force that reaches far into space. For many giant planets, this picture works remarkably well. Then scientists looked more closely at Saturn. They expected to find that its magnetic field leaned slightly away from its axis of rotation, just as Earth's does and just as Jupiter's does. Instead, they found something astonishing. Saturn's magnetic field appears to be almost perfectly aligned with the planet's rotation. The difference is so incredibly small that, even after years of careful measurements, researchers have struggled to explain how such a perfectly balanced magnetic field can exist. This may sound like a small detail. After all, what difference could a tiny angle possibly make? In science, however, small differences often reveal enormous mysteries. Current theories suggest that planetary magnetic fields naturally develop at least a slight tilt. That tiny misalignment helps scientists understand how the moving material inside a planet generates magnetism. Saturn refuses to follow that expectation. It behaves almost as though nature has quietly hidden one important piece of the puzzle. Some researchers believe the answer may lie deep within the planet itself. Perhaps the electrically conducting hydrogen moves in ways we have not yet fully understood. Perhaps additional layers inside Saturn gently reshape the magnetic field before it reaches space. Or perhaps giant planets still have lessons to teach us that our current theories have not yet learned to describe. For now, no one can say with complete certainty. And there is something wonderfully satisfying about that. Even after centuries of astronomy, decades of spacecraft exploration, and countless scientific studies, one of the Enceladus, this unusual magnetic field, has created another challenge as well. You might imagine that measuring the length of a day on a planet would be straightforward. Simply watch the planet rotate once. On Earth, that works perfectly because mountains, continents, and oceans provide clear landmarks. Saturn offers no such convenience. Its clouds move at different speeds. Some atmospheric bands race ahead while others drift more slowly. The visible clouds do not all rotate together, making it surprisingly difficult to determine exactly how fast the planet itself is spinning underneath. For many years, scientists tried using Saturn's magnetic field as a kind of invisible clock. On other giant planets, subtle variations in the magnetic field repeat with each rotation, making it possible to calculate the length of a day. But Saturn's beautifully symmetrical magnetic field refused to cooperate. It remained almost perfectly steady. The very feature that makes Saturn so scientifically fascinating also made one of its most basic measurements unexpectedly difficult. Today, researchers estimate that one Saturnian day lasts a little more than 10.5 hours. Even so, the exact value continues to be refined as new observations improve our understanding of the planet's hidden interior. That rapid rotation has a visible consequence. As Saturn spins, its equator gently bulges outward, while its poles become slightly flattened. Imagine a baker spinning a ball of soft dough on a wheel. The faster it turns, the more the middle slowly widens. Saturn behaves in much the same way, although gravity continually works to hold the giant planet together. The result is a world that is not a perfect sphere, but one that is subtly stretched around its middle by its own rapid rotation. This constant spinning influences almost everything around it: the winds, the storms, the magnetic field. Even the graceful rings that have captivated observers for centuries exist within the invisible influence of Saturn's gravity and magnetism. Those rings may appear delicate from afar, like thin circles drawn around a golden world. But as we slowly drift outward once again, they begin revealing themselves not as solid bands of ice, but as one of the most intricate and dynamic structures anywhere in the solar system. Their beauty is obvious. Their true complexity is only just beginning to emerge. If Saturn has a signature, it is undoubtedly its rings. Even someone who has never studied astronomy can usually recognize Saturn in an instant. A simple sketch of a golden planet surrounded by a graceful oval is often enough. Few worlds possess such an unmistakable silhouette. For centuries, those luminous rings have transformed Saturn from simply another distant planet into one of the most recognizable objects in the night sky. And yet, like so many things in nature, their first impression hides a far richer reality. From millions of kilometers away, the rings appear smooth and continuous, almost as though someone had placed a perfectly crafted disk around the planet. They seem solid enough that you might imagine landing on them or walking carefully across their surface. But as our journey carries us closer, that illusion quietly begins to dissolve. The rings are not solid at all. Instead, they are made from countless individual pieces traveling together around Saturn. Some are no larger than grains of dust. Others resemble pebbles scattered across a riverbed. Many are the size of houses, while a few are even larger, stretching across distances that would rival mountains on Earth. Each fragment follows its own path. Each responds to Saturn's gravity. Together, they create one of the most beautiful structures in the solar system. Imagine standing on a quiet beach just after sunrise. From a distance, the shoreline appears smooth and almost continuous. But as you walk closer, the sand reveals itself as millions upon millions of tiny grains. No single grain creates the beach by itself. Only together do they form the broad landscape stretching before you. Saturn's rings are remarkably similar. Their breathtaking beauty emerges not from one enormous object, but from an almost unimaginable collection of individual pieces moving together through space with extraordinary precision. Most of these fragments are made largely of water ice. That simple fact explains much of the ring's remarkable brightness. Ice reflects sunlight extremely well. As light from the distant sun reaches Saturn, countless frozen particles scatter it in every direction, causing the rings to glow with a soft brilliance against the darkness of space. Mixed among the ice are smaller amounts of rocky material and dust, quietly adding texture and subtle variation to the vast structure. Seen from nearby, the rings would never appear perfectly still. Every fragment is in motion. Some orbit slightly faster, others move more slowly. Those closest to Saturn complete an orbit in less time because the planet's gravity pulls on them more strongly. Farther outward, the journey becomes longer, and the particles travel at gentler speeds. This graceful variation creates a remarkable cosmic dance. Imagine runners on different lanes of a circular track. The runner closest to the center follows the shortest path and naturally completes each lap more quickly. A runner on the outer lane must travel farther to finish the same circuit. The particles within Saturn's rings behave in much the same way. There is no conductor giving instructions, no invisible hand carefully arranging every movement. Gravity alone quietly organizes billions upon billions of icy fragments into an elegant system that has endured for immense stretches of time. As spacecraft gradually revealed greater detail, scientists discovered that Saturn's rings were even more intricate than anyone had imagined. What appeared from Earth to be only a handful of broad rings turned out to contain hundreds of smaller ringlets. These ringlets resemble delicate threads woven together into an enormous celestial fabric. Some are bright and sharply defined. Others are faint, almost disappearing into the surrounding darkness before gently emerging once again. Looking closely at high-resolution images from the Cassini spacecraft is a little like examining a piece of finely woven silk under a magnifying glass. Patterns emerge everywhere: thin lines, soft curves, subtle textures, features so delicate that they seem almost impossible to preserve across such enormous distances. In some places, gentle ripples travel through the rings. These are not waves moving through water, but slow patterns created as gravity nudges countless particles together. Imagine tossing a small pebble into an otherwise calm pond. Concentric ripples spread outward across the surface, carrying energy while the water itself simply rises and falls in place. Saturn's rings display something surprisingly similar. Invisible gravitational influences send broad waves flowing through the countless icy fragments, creating graceful patterns that slowly move across the ring system. Elsewhere, the rings appear gently folded or slightly twisted, almost like fabric caught by a soft breeze. Again, nothing is pushing them in the ordinary sense. Instead, gravity patiently sculpts these structures over time, producing shapes of extraordinary elegance. The more scientists observe the rings, the more they realize they behave almost like a living system. Not alive, of course, in the biological sense, but constantly changing, constantly responding, constantly adjusting to the invisible forces surrounding them. One of the greatest questions has been surprisingly simple. Where did these magnificent rings come from? For many years, astronomers imagined that the rings formed alongside Saturn itself more than 4 billion years ago, surviving since the birth of the solar system. More recent observations have suggested another intriguing possibility. Perhaps the rings are much younger. Some researchers think they may have formed after an ancient icy moon wandered too close to Saturn. As gravity pulled upon the moon with overwhelming strength, it may have broken apart, scattering enormous quantities of ice into orbit. Over time, those fragments gradually spread into the beautiful rings we see today. It is a compelling idea. If true, Saturn's greatest symbol may actually be a beautiful reminder of an ancient catastrophe. Yet the story is not settled. Other observations still leave room for older origins, and scientists continue debating exactly when the rings formed. Like many of Saturn's mysteries, the evidence offers fascinating clues without delivering a final answer. Perhaps that uncertainty is part of what makes the rings so captivating. They are not merely objects to admire, they are questions written across space, questions about gravity, about time, about destruction and renewal, about how beauty can emerge from countless small pieces moving together with quiet harmony. As we continue drifting alongside these luminous bands, another surprise slowly comes into view. Tiny moons, almost unnoticed against Saturn's immense presence, are quietly shaping the rings every single day. Though small compared with the giant planet, their gentle gravitational influence leaves delicate fingerprints throughout the icy particles, guiding, sculpting, and preserving the extraordinary patterns that have fascinated generations of observers. As we continue gliding alongside Saturn's magnificent rings, it becomes increasingly clear that they are far from static. Their graceful appearance suggests perfect stillness, but every shimmering band is constantly changing in subtle ways. Tiny particles shift their positions. Delicate waves ripple outward. Narrow gaps remain astonishingly clean, while other regions gather countless fragments into bright, concentrated bands. At first glance, it might seem impossible that such remarkable order could emerge naturally. These are Saturn's shepherd moons. Compared with Saturn itself, they are almost insignificant. Some are only a few dozen kilometers across, far too small to command attention beside a planet nearly 120,000 kilometers in diameter. If Saturn were the size of a large stadium, many of these moons would be no larger than small pebbles scattered across the seats. And yet, despite their size, they possess an extraordinary ability. Through nothing more than gravity, they gently shape one of the most beautiful structures in the solar system. Imagine walking through fresh snow on a calm winter morning. As you move, your footsteps leave narrow paths that remain visible long after you have passed. You do not need to push the snow aside with great force. Simply moving through it is enough to create lasting patterns. The shepherd moons do something remarkably similar. As they travel around Saturn, their gravity gently influences nearby ring particles. The effect is incredibly subtle for any individual piece of ice, but across millions upon millions of particles, those tiny influences accumulate into graceful structures that can stretch for thousands of kilometers. One of the best-known examples is a small moon named Pan. Rather than orbiting outside the rings, Pan travels within a narrow gap known as the Anchor Gap. As it moves, its gravity continuously gathers nearby particles, preventing the gap from filling back in completely. If Pan were suddenly removed, the surrounding ice would gradually drift inward once again, slowly erasing the neat opening that has existed for countless years. Another tiny moon, Daphnis, performs a similar role within an even narrower gap. What makes Daphnis especially captivating is the effect it creates along the edges of the surrounding rings. As the little moon travels on its orbit, it raises gentle waves in the nearby particles. The scene is surprisingly familiar. Imagine a small boat moving slowly across a peaceful lake. The boat itself may be modest, but delicate waves spread outward behind it, reaching places far beyond the vessel's own size. Daphnis leaves behind a similar signature. Its gravity creates graceful ripples that travel through the surrounding ring particles, sculpting delicate patterns that were photographed in extraordinary detail by the Cassini spacecraft. Looking at those images, it is difficult not to feel a sense of quiet wonder. Something only a few kilometers wide is gently shaping structures thousands of kilometers across, using nothing more than the invisible pull of gravity. It is one of the clearest reminders that in the universe, influence is not always measured by size. Sometimes the smallest participants quietly guide the grandest performances. The farther scientists looked, the more they realized that Saturn's rings behave almost like an enormous musical instrument. Not because they produce sounds that human ears could hear in space, where there is no air to carry them, but because gravity creates repeating rhythms throughout the entire system. Astronomers often describe these interactions using the idea of resonance. The word may sound technical, but the underlying idea is wonderfully simple. Imagine pushing a child on a playground swing. If each gentle push arrives at just the right moment, the swing climbs higher with very little effort. Push at the wrong time, and almost nothing happens. Gravity can behave in much the same way. When moons repeatedly pass through certain positions, their gentle gravitational tugs occur with remarkable regularity. Over thousands, millions, or even billions of orbits, those tiny repeated influences gradually organize the surrounding particles into new patterns. One of Saturn's largest moons, Mimas, provides one of the most famous examples. Mimas is perhaps best known for the enormous impact crater that gives it the appearance of a giant eye when viewed from certain angles. But its greatest influence may lie not on its own surface, but within Saturn's rings. The broad gap known as the Cassini division separates two of the brightest ring regions. For many years, people imagined that this dark band was simply empty space carved into the ring system. The reality is more subtle. The Cassini division is not completely empty. Instead, it contains far fewer particles than the brilliant rings surrounding it. One of the primary reasons for this remarkable structure is the repeated gravitational influence of Mimas. Each time particles attempt to settle into certain orbits, Mimas gently nudges them again and again. A single encounter changes very little. But over immense periods of time, those repeated nudges slowly alter the particles' paths, making those particular orbits increasingly difficult to occupy. The result is a broad, elegant gap that has fascinated observers since the 17th century. What makes this story especially beautiful is that no moon is consciously shaping the rings. There is no design, no intention, only gravity patiently doing what gravity has always done. Tiny influences repeated over extraordinary lengths of time gradually become magnificent structures visible across the solar system. This same principle appears again and again throughout Saturn's family of moons. Some gently confine narrow rings, others create spiral waves. Still others produce subtle distortions that slowly travel through the countless icy particles, like ripples spreading across still water. Seen individually, each interaction appears almost insignificant. Seen together, they reveal something much larger. Saturn is not merely a planet surrounded by separate objects. It is a single connected system. The planet influences the rings influence the moons reshape the rings. Gravity quietly links every member of this celestial family into one immense choreography that has continued for billions of years. The more closely we observe Saturn, the less it resembles a collection of isolated worlds. Instead, it begins to feel like an ecosystem, not one built from forests or oceans, but from gravity, motion, and time. Every orbit affects another. Every gentle pull leaves a lasting mark. Every fragment participates in a story far larger than itself. And among all the companions circling this extraordinary giant, two moons stand apart from the rest. One hides rivers and lakes unlike any found elsewhere in the solar system. The other quietly sends enormous plumes of water into the darkness of space, hinting that beneath its frozen shell, an ocean may have remained warm for billions of years. Their stories would transform Saturn from a beautiful planet into one of the most promising places in humanity's search for life beyond Earth. The farther we travel through Saturn's realm, the more we begin to understand that the planet itself is only part of the story. Surrounding the giant world is a remarkable family of more than 140 known moons. Some are little more than irregular pieces of rock and ice, quietly circling their parent planet without attracting much attention. Others are so small that they resemble oversized mountain peaks drifting through space. But a handful of them have become worlds in their own right. Each possesses its own history, its own landscape, its own mysteries. Among them, two stand apart from all the others. One is wrapped in a thick orange atmosphere so dense that its surface remained hidden from human eyes for centuries. The other appears small, bright, and frozen, yet quietly sends towering fountains of water into the darkness of space. Together, they have transformed Saturn into one of the most scientifically exciting destinations in the entire solar system. Let us begin with Titan. Titan is Saturn's largest moon and the second largest moon in the solar system. It is even larger than the planet Mercury, although it contains far less mass because much of it is made of ice rather than rock. From a distance, Titan looks surprisingly simple, a smooth orange sphere. No obvious continents, no bright ice caps, no dramatic mountain ranges. For many years, astronomers could see almost nothing beneath its thick atmosphere. Dense layers of haze completely concealed the landscape below, making Titan seem like a world that preferred to keep its secrets. Only when spacecraft finally arrived did those secrets begin to emerge. Beneath the orange haze lies a landscape unlike anything else yet discovered. There are rivers, there are lakes, there are seas, there are valleys carved by flowing liquid. At first, this description sounds wonderfully familiar, almost like Earth viewed from a great distance. But there is one remarkable difference. The rivers and lakes on Titan are not filled with water. They are filled with liquid methane and liquid ethane. Here on Earth, methane is a gas that rises invisibly into the atmosphere. On Titan, where temperatures are unimaginably cold, methane becomes a liquid, flowing gently across the landscape, much as water flows across our own planet. It is one of the most beautiful examples of how the same laws of physics can create entirely different worlds. Imagine visiting a place where rain falls, rivers wind across broad plains, clouds gather overhead, and lakes shimmer beneath the sky. Then imagine discovering that none of those familiar sights are made from water. Titan has its own weather cycle. Clouds form, rain falls, liquid gathers into rivers, rivers flow into lakes. The liquid then slowly evaporates, rising once more into the atmosphere before beginning the journey again. It is, in many ways, a reflection of Earth's own water cycle. Only the ingredients have changed. This extraordinary similarity has made Titan one of the most valuable natural laboratories for planetary scientists. By studying its atmosphere and weather, researchers gain new perspectives on how climates evolve and how different environments respond to the same physical laws. The surface itself is equally fascinating. Vast fields of dark dunes stretch across some regions, sculpted by gentle winds over immense periods of time. Elsewhere, broad lakes remain almost perfectly calm, their smooth surfaces reflecting the dim sunlight that reaches Saturn's distant neighborhood. The sunlight there is very different from what we experience on Earth. Standing on Titan during the daytime would feel a little like walking outdoors shortly after sunset, when the world is still visible but wrapped in soft, muted light. The thick atmosphere scatters that gentle sunlight even further, giving the landscape a quiet, dreamlike appearance. It is not difficult to imagine why Titan has captured the imagination of scientists for generations. Yet another moon may be even more surprising. Enceladus is tiny compared with Titan. Its diameter is only about 500 kilometers, small enough that several Enceladus-sized worlds could fit comfortably across the width of Earth's moon. For a long time, few people expected such a small object to hold many surprises. Then the Cassini spacecraft flew past it. What it discovered changed everything. Towering plumes of water vapor and tiny ice particles were erupting from long fractures near Enceladus's south pole, shooting hundreds of kilometers into space. The sight was astonishing. Imagine standing beside a frozen lake during winter, Without warning, great fountains of water suddenly burst upward through cracks in the ice, sparkling in the sunlight before gently falling back again. That image comes surprisingly close to what Cassini observed, although on Enceladus, the escaping material does not simply fall back to the surface. Some of it escapes into space entirely, helping replenish Saturn's faint outer rings. These towering plumes provided scientists with something extraordinarily valuable. Instead of drilling through kilometers of ice to reach the hidden ocean below, Cassini could simply fly through the material already being released into space. As the spacecraft passed through the plumes, its instruments detected water, salts, simple organic molecules, and tiny mineral particles that appear to have formed in warm water deep beneath the icy crust. Those discoveries suggested something remarkable. Far below Enceladus's frozen surface lies a global ocean. Even more exciting, evidence points toward hydrothermal activity on the seafloor, something broadly similar to underwater hot springs found in Earth's oceans. On our own planet, such environments support rich communities of living organisms, despite receiving no sunlight at all. This does not mean life exists on Enceladus. Scientists have never found direct evidence of living organisms there, but the Moon appears to possess several of the ingredients that life as we know it requires: liquid water, useful chemical building blocks, an ongoing source of energy. Together, these discoveries transformed Enceladus from an overlooked icy moon into one of the most promising places in the solar system to continue searching for signs of life. It is remarkable how often the universe rewards curiosity. A moon once dismissed as a frozen ball of ice now invites us to ask one of humanity's oldest questions: are we truly alone? Saturn's moons remind us that extraordinary discoveries are not always found on the largest worlds. Sometimes they quietly wait on small, distant companions, circling patiently around a giant planet beneath the soft glow of ancient rings. And it was one remarkable spacecraft, arriving after a journey that lasted nearly 7 years, that allowed humanity to witness many of these wonders for the very first time. For most of human history, Saturn was little more than a beautiful point of light. Even after the invention of the telescope, it remained frustratingly distant. Early astronomers could admire its rings, but they could only guess what kind of world lay beneath those pale golden clouds. As telescopes improved, more details slowly emerged. New moons were discovered. The rings revealed unexpected gaps and delicate structures. Yet Saturn still guarded most of its secrets behind an immense gulf of space. Everything began to change during the second half of the 20th century. Humanity had entered the age of planetary exploration. Instead of observing distant worlds from Earth, we had learned to send robotic explorers across the solar system itself. The first visitors to Saturn were brief guests. The Pioneer 11 spacecraft flew past the giant planet in the late 1970s, providing humanity with its first close look at Saturn's environment. For the first time, instruments measured its magnetic field directly, photographed its clouds from nearby, and confirmed that this distant world was far more complex than anyone had imagined. A few years later came Voyager 1 and Voyager 2. Together, they transformed Saturn from a distant curiosity into a richly detailed planetary system. Their cameras revealed astonishing structures within the rings, discovered new moons, and captured breathtaking views that inspired an entire generation of scientists. Yet these remarkable spacecraft shared one important limitation. They never stayed. Each flew past Saturn only once before continuing its journey toward the outer reaches of the solar system. Imagine visiting one of the world's greatest cities for only a single afternoon. You might admire its skyline, walk a few streets, and take beautiful photographs. But you would never truly come to know the rhythm of daily life, the changing seasons, or the subtle details that only reveal themselves with time. Scientists dreamed of something different, They wanted a spacecraft that would remain with Saturn for years rather than hours. That dream became the Cassini-Huygens mission. Named in honor of two pioneering astronomers, Giovanni Domenico Cassini and Christian Huygens, the mission represented one of the most ambitious international collaborations ever undertaken in planetary science. Building such a spacecraft required years of careful engineering. Reaching Saturn required even more patience. After its launch from Earth, Cassini did not travel directly outward. Instead, it followed an elegant path through the inner solar system, passing close to Venus twice, then Earth, and later Jupiter. Each planetary encounter gently increased its speed through a technique often compared to borrowing a tiny amount of momentum from a moving world. It was a remarkably efficient way to cross the vast distances between planets. Nearly 7 years after leaving Earth, Cassini finally arrived at Saturn. Its arrival was anything but routine. To enter orbit safely, the spacecraft had to fire its main engine, while passing through the narrow gap between the outer rings and the planet itself. It was a carefully planned maneuver, requiring extraordinary precision. When the engine shut down exactly as expected, humanity had accomplished something unprecedented. For the first time, a spacecraft was orbiting Saturn. From that moment onward, the giant planet was no longer an occasional destination. It became a place we could visit again and again. One of Cassini's companions carried an especially important mission. Attached to the spacecraft was a small lander called Huygens. While Cassini remained in orbit around Saturn, Huygens separated and began a slow descent toward Titan. No spacecraft had ever landed in the outer solar system before. As Huygens drifted downward beneath Titan's thick orange atmosphere, parachutes gently slowed its descent. For more than 2 hours, its instruments recorded changing temperatures, shifting winds, and increasingly detailed views of a landscape that no human being had ever seen. When it finally reached the surface, Huygens revealed a world unlike any other. Rounded stones rested along what appeared to be an ancient river channel. The ground looked damp, though not with water. The orange sky above cast a soft glow across the landscape, creating a scene that felt strangely familiar and completely alien at the same time. For a brief period before its batteries were exhausted, Huygens allowed humanity to stand, through robotic eyes, on a moon nearly 1.5 billion kilometers from the Sun. Meanwhile, Cassini continued its own remarkable work. Year after year, it circled Saturn, patiently observing the planet through changing seasons. Unlike Earth, where the seasons change every few months, Saturn takes nearly 30 Earth years to complete one orbit around the Sun. During Cassini's mission, scientists witnessed seasonal changes unfolding across the giant planet, watching storms evolve, clouds shift, and sunlight gradually illuminate different parts of the ring system. This long perspective proved invaluable. Cassini observed enormous storms forming and expanding across the atmosphere. It watched delicate waves ripple through the rings. It discovered that tiny moons were quietly sculpting ring edges with remarkable precision. It flew repeatedly past Titan, mapping lakes, rivers, mountains, and vast fields of dunes hidden beneath the moon's orange haze. Perhaps even more surprising were its encounters with Enceladus. Again and again, Cassini passed through the towering plumes erupting from the moon's south pole. Instead of observing those icy fountains only from a distance, the spacecraft sampled them directly. Those brief passages transformed our understanding of Enceladus. The instruments detected water, salts, organic molecules, and tiny mineral particles that strongly suggested warm water was interacting with rock deep beneath the icy crust. A small frozen moon had unexpectedly become one of the most promising places to search for life beyond Earth. As the years passed, Cassini also revealed that Saturn itself was still full of surprises. It provided evidence that helium rain may help warm the planet from within. It helped scientists conclude that Saturn's interior is likely far more diffuse than previously imagined, rather than consisting of a sharply defined central core. It revealed that the rings are far more dynamic than anyone had expected, constantly changing under the quiet influence of gravity. Eventually, however, every mission must come to an end. By 2017, Cassini was running low on the fuel needed to control its orientation. Mission planners faced an important decision. Some of Saturn's moons, particularly Titan and Enceladus, possess environments that scientists hope to study for signs of life in the future. Even though Cassini had been carefully sterilized before launch, engineers wanted to eliminate even the smallest possibility that the spacecraft might accidentally collide with one of those worlds many years later. So they chose a different farewell. Cassini began a series of daring final orbits, repeatedly diving through the narrow space between Saturn's innermost rings and the cloud tops below. No spacecraft had ever flown there before. Each pass returned precious new measurements of Saturn's gravity, magnetic field, atmosphere, and rings, collecting information that scientists are still studying today. Finally, on a quiet day in September 2017, Cassini made one last descent. As it entered Saturn's upper atmosphere, increasing friction slowly overcame the spacecraft. It continued transmitting valuable scientific data until the very last moments, before finally falling silent forever. It was not simply the end of a mission. It was the final chapter of an explorer that had spent more than 13 years revealing one of the solar system's greatest masterpieces. And despite everything Cassini taught us, Saturn still holds mysteries that continue to invite future explorers to return. By the time Cassini completed its final journey into Saturn's atmosphere, it had transformed our understanding of the ringed giant in ways few people could have imagined. And yet, perhaps the mission's greatest achievement was something even more remarkable. It revealed just how much we still do not know. In science, every answer has a curious habit of opening several new questions. A mystery solved often uncovers another, waiting quietly beneath it, rather like lifting one smooth stone, only to discover an entirely new landscape underneath. Saturn is one of the finest examples of this gentle pattern. The closer humanity has looked, the more beautifully complicated the planet has become. One of the oldest mysteries concerns the rings themselves. At first glance, they seem timeless. It is easy to imagine them circling Saturn since the earliest days of the solar system, remaining almost unchanged while billions of years quietly passed. For many decades, that was exactly what scientists believed. If Saturn formed more than 4.5 billion years ago, surely its magnificent rings must have formed alongside it. But recent observations have introduced a surprising possibility. The rings may be far younger than the planet they surround. When Cassini carefully measured the amount of dark dust mixed among the bright ice particles, researchers noticed something intriguing. The rings appear remarkably clean. Over billions of years, tiny grains of dust drifting through the solar system should gradually darken the ice, much as fresh snow slowly becomes dirtier after days of wind and weather. Yet Saturn's rings remain astonishingly bright. One possible explanation is that they simply have not existed long enough to collect very much dust. Perhaps they formed only a few 100 million years ago, relatively recently in the history of the solar system. If that idea is correct, then humanity happens to exist during a rather fortunate moment in cosmic history. We would be witnessing Saturn while its spectacular rings are still young enough to shine with extraordinary brilliance. Not every scientist agrees with this interpretation. Some researchers argue that hidden processes may continually refresh the rings, exposing cleaner ice and making an older system appear younger than it truly is. Others suggest that the rate at which dust accumulates may not yet be fully understood. For now, the debate remains open. Like many of Saturn's greatest puzzles, the evidence points in several intriguing directions without settling on a single answer. The rings also appear to be changing even today. Cassini discovered that tiny particles from the rings do not remain in orbit forever. Some gradually drift inward, following invisible magnetic pathways until they eventually fall into Saturn's upper atmosphere. Scientists sometimes describe this slow process as ring rain. The name is wonderfully descriptive. Imagine the gentle snowfall of a quiet winter evening. Individual flakes seem almost insignificant. Yet, hour after hour, day after day, they gradually transform the entire landscape. Ring rain behaves in much the same way. Minute particles slowly leave the rings and descend into Saturn's atmosphere. No one watching could ever notice the process unfolding in real time, but over immense spans of time, the effect becomes significant. The rings are slowly losing material. This realization has led to another profound question. Will Saturn's rings disappear completely? The answer appears to be yes. Not tomorrow, not in thousands of years, probably not even in millions of years. But over hundreds of millions of years, the graceful rings we admire today may gradually become thinner, fainter, and eventually vanish altogether. It is a quietly humbling thought. The feature that has defined Saturn in human imagination may represent only one chapter in the planet's extraordinarily long history. Long before the rings existed in their present form, Saturn was already circling the Sun. Long after they have faded away, the giant planet will almost certainly continue its patient journey through space. Another mystery lies hidden within the planet itself. Earlier, we explored Saturn's remarkably symmetrical magnetic field. Despite years of careful measurements, scientists still cannot fully explain why it is so perfectly aligned with the planet's rotation. Computer models reproduce many features of giant planets with impressive accuracy, yet Saturn continues to resist complete explanation. It is rather like hearing a familiar melody played on an unfamiliar instrument. The notes sound almost correct. Almost. But something subtle remains different enough to remind us that we have not yet heard the entire composition. The mystery extends to Saturn's rotation as well, because the visible clouds move at different speeds. Determining exactly how fast the deep interior rotates remains surprisingly difficult. Even after decades of spacecraft exploration, researchers continue refining their estimates, using tiny clues hidden within gravity measurements, atmospheric oscillations, and the planet's magnetic environment. Sometimes the largest worlds prove to be the hardest to understand. Then there is the question of Saturn's interior. Cassini provided compelling evidence that the planet may not possess the sharply defined central core that scientists once imagined. Instead, its deepest layers may blend together across an enormous region, where rock, ice, hydrogen, and helium gradually mix rather than remaining neatly separated. If this picture is correct, it changes more than our understanding of Saturn alone. It influences how astronomers think giant planets form throughout the universe. Today, thousands of planets have been discovered orbiting distant stars. Many resemble Saturn far more closely than they resemble Earth. By understanding the hidden interior of one familiar giant, we gain valuable clues about countless worlds scattered across our galaxy. In that sense, Saturn becomes far more than a single destination. It becomes a natural laboratory, a place where the laws shaping giant planets can be observed, tested, and gradually understood before being applied to worlds so distant that we may never see them directly. Even Saturn's moons continue to raise profound questions. Titan may preserve chemical processes resembling those that occurred on the young Earth long before life appeared. Enceladus continues to tempt scientists with its hidden ocean, where liquid water, useful chemistry, and internal heat exist together beneath a frozen shell. Future missions may one day return to these remarkable worlds with instruments far more capable than those Cassini carried. Some may even search directly for evidence of life. Whether those searches succeed or not, Saturn has already taught us something enduring. The universe rarely reveals all of its secrets at once. Instead, it invites patience, observation, curiosity. Each discovery becomes a beginning rather than an ending, encouraging us to look a little closer, ask a little more carefully, and remain open to the possibility that nature still holds wonders beyond anything we have yet imagined. And perhaps that is Saturn's greatest gift, not simply the beauty of its rings or the grandeur of its storms, but its quiet reminder that even after centuries of exploration, there are still places in the universe capable of surprising us. As our quiet journey through Saturn's remarkable world begins to draw toward its natural resting place, it is worth pausing for a gentle moment to look back, not to list every discovery we have encountered, but to appreciate the larger picture that has slowly emerged. When we first approached Saturn, it appeared almost impossibly simple. A pale golden sphere, a graceful set of rings, a distant light drifting silently around the sun. It seemed almost peaceful enough to understand at a glance. Yet with every gentle step closer, that first impression quietly unfolded into something far richer. The calm clouds concealed some of the fastest winds anywhere in the solar system. The soft colors hid storms that could swallow entire planets. Deep beneath the atmosphere, familiar elements gradually transformed into forms unlike anything found on Earth's surface, while an invisible ocean of electrically conducting hydrogen quietly helped generate one of the most extraordinary magnetic fields known to science. Even the famous rings, which at first seemed like smooth circles wrapped around the planet, became something entirely different as we moved closer. Rather than solid bands, they revealed themselves as countless fragments of ice and rock, each following its own quiet path around Saturn. Each tiny particle obeys the same simple law of gravity. Together, they create a masterpiece visible across billions of kilometers of space. Perhaps that is one of the most comforting lessons Saturn offers. Extraordinary beauty does not always require extraordinary complexity. Sometimes it emerges from countless small things moving together with remarkable patience. The rings also remind us that beauty is rarely permanent. Even now, tiny particles are slowly drifting away, returning to the planet that has guided them for so long. Given enough time, the rings may one day fade completely. Future civilizations, separated from us by hundreds of millions of years, might look towards Saturn and never know that magnificent rings once surrounded the giant world. There is something quietly humbling about that thought. It reminds us that the universe is never standing still. Even the grandest structures change. Sometimes the changes happen so slowly that no single lifetime can witness them. Yet change continues all the same, patient and uninterrupted. The moons surrounding Saturn tell a similar story. Titan showed us that familiar ideas can appear in unfamiliar forms: rivers, lakes, rain, clouds, all existing in a world where water is frozen as hard as stone, while other liquids quietly take its place. Enceladus revealed that even a small frozen moon can conceal surprising warmth beneath its icy shell. For generations, such places were little more than distant points of light. Today, they have become some of the most promising destinations in humanity's continuing search to understand whether life might exist elsewhere in the universe. Whether that search ultimately discovers living organisms or not, it has already expanded something equally valuable: our imagination. Every new mission reminds us that the universe is often more inventive than we first expect. Worlds that once seemed ordinary become extraordinary. Ideas that once sounded impossible gradually become accepted parts of scientific understanding. Questions that once had no answers slowly give way to new discoveries, which in turn invite new questions. That gentle rhythm has accompanied science for centuries. It is unlikely ever to end. Cassini's long voyage captured this spirit beautifully. For more than a decade, the spacecraft quietly circled Saturn, never rushing, never demanding immediate answers. Orbit after orbit, it simply observed, measured, recorded, patiently collecting small pieces of a puzzle far too large to solve all at once. There is something deeply reassuring in that approach. Not every mystery needs to be solved immediately. Sometimes understanding grows slowly, almost unnoticed, through careful attention and quiet curiosity. Perhaps that lesson extends beyond astronomy. In our own lives, we often hope for quick answers. We search for certainty. We want complicated questions to resolve themselves neatly. Nature rarely works that way. Saturn certainly does not. Instead, it teaches patience, layer after layer, orbit after orbit, season after season. The picture becomes clearer, not because the universe grows simpler, but because we gradually learn how to look more carefully. It is remarkable that a planet nearly 1.5 billion kilometers from the Sun can offer such a gentle reminder. Distance does not diminish connection. The same laws that guide Saturn's rings also guide falling leaves on Earth. The gravity shaping distant moons is the very same force keeping our own feet firmly on the ground. The atoms drifting through Saturn's atmosphere were forged billions of years ago inside ancient stars, just as the atoms within every living cell of your own body once shared that same cosmic beginning. In that sense, Saturn is not completely separate from us. It is another expression of the same universe, another chapter in the same story, another quiet reminder that everything around us, from the smallest grain of dust to the largest planet, belongs to one vast and interconnected cosmos. Perhaps that is why Saturn has fascinated humanity for so long, not simply because it is beautiful, not simply because it possesses magnificent rings, but because every closer look gently invites us to widen our own perspective. The universe is larger than we imagine, more subtle than we expect, more patient than we often allow ourselves to be, and somehow, despite its unimaginable scale, it still follows elegant patterns that we are capable of discovering, one careful observation at a time. As the image of Saturn slowly grows smaller once again, its golden clouds blending gently into the darkness, it becomes easier to appreciate just how fortunate we are to live in a time when such distant worlds are no longer beyond our reach. We may never stand beneath Saturn's clouds or walk along the shores of Titan's silent lakes. We may never watch the icy fountains of Enceladus rise against a black sky with our own eyes. Yet through science, curiosity, and the quiet determination of countless people working across generations, those distant places have become part of our shared understanding of the universe. And perhaps tonight, as your thoughts become a little slower and a little quieter, Saturn will remain in your imagination, not merely as the planet with beautiful rings, but as a gentle symbol of curiosity itself. A world that reminds us there is always something more to discover, something more to understand, something more to wonder about. Thank you for joining this peaceful journey through one of the solar system's most extraordinary worlds. Whether you are simply relaxing, quietly reflecting, or already beginning to drift towards sleep, may the graceful rings of Saturn continue their silent journey across your thoughts, just as they have circled their giant world for ages beyond memory. Until our paths cross again beneath another star-filled sky, rest well, sleep peacefully, and good night.